In the previous lesson, we were introduced to the 6 trig functions. Today we're going to focus on sine, cosine, and tangent and use those in our right triangle applications. Before we get into the actual problems, let's take a look at how to find these things on our calculator, because that's a very important tool we're going to need today. So I've got a picture here of the generic scientific calculator that most of us have. Sine, cosine, and tangent. We're going to be using these buttons right here. Sine, cosine, and tangent. Alright, so find those on your calculator for me. If you're using your phone, that's fine. Just make sure you turn your phone into landscape mode so more buttons pop up on the calculator. Alright, so your process is going to be a little bit different than mine, but I'll explain how to do that. So we're just going to practice real quick. Alright, let's put a couple of these down. So this first one is going to be sine of 25 degrees. So we want to find what that is. It's going to be a decimal, and we want to find that on the calculator. So if you have more questions about this, let me know. I'll help you out with your calculators. But for right now, if you got a calculator that looks like this, you're going to go ahead and press sine first. So this sine button, and then press 25. So sine 25, hit enter. And you're going to come out with a decimal. It should be around 0.423. So check on your calculator, make sure you get close to that. If you're not getting that same answer, we might need to check, make sure you are in degrees and not radians, and I'll show you how to find that in a sec. Get rid of that marking. So if you're not getting the same number as me, you might need to play around with this button right here, DRG. If it's not marked as D for degrees, you might be in R, which is radians, and you need to change it back to degrees. Okay, if you need help, let me know. Just reach out to me. But for right now, if you're getting the same number as me, then everything is good. Okay, let's try another one. So go ahead and try the cosine of 50 degrees. So cosine would be right here, and then you hit the 50 and then enter. And this time you should get an answer of 0.643. If you're doing this on your phone, you want to put the number first, so you'll put 50 first and then hit cosine, or 25 first and then hit sine. So the phone's a little bit backwards. Calculator, you put the trig function in first. Okay, and then finally one more. Let's use the tangent button. Tangent of 73 degrees. So we would hit tangent, the 7, the 3, and then enter. And you should get 3.271. So I just want to make sure you know how to find this stuff on your calculator. Okay. So we're going to run into these once we start our examples here, and I'll refer back to the calculator whenever we need to use that. So for example, these problems are going to tell us to find x, or solve for x. And they're going to give us a picture here. We've got ourselves a right triangle. They give us over here, this is a 35-degree angle. And they tell us that this side is 9 and this side is x. Alright, so a couple lessons ago we solved for x, or we solved for the missing sides, but these were special right triangles, either 30, 60, 90 or 45, 45, 90. But here we have a 35-degree angle, and I'm going to mark that off, 35 degrees. That's not one of our special angles. So when it's not one of the special angles, we have to use trig. So either sine, cosine, or tangent. So the first thing you want to do is label your sides. Okay? So I marked off this angle here. According to that angle, we have a 9 and we have an x. I don't know anything about this lower one. So the 9 and the x, let's put some names on this. The 9 is across from the 90-degree angle, so that's called the hypotenuse. Our focus angle here is the 35. Remember we called that theta before? The side across from that, that's our x. That one is the opposite side. So the side that we don't have is the adjacent, but we don't need it. So let's see what we have. We have hypotenuse and we have opposite. So if we think about SOHCAHTOA, which of our trig functions uses opposite and hypotenuse? O and H. So that goes with sine. So we're going to go ahead and write that down. Sine of theta is opposite over hypotenuse. And let's fill in everything that we have. So sine of theta. Now I do know what theta is. Theta is 35 degrees equals. The opposite is x, and the hypotenuse we have labeled as 9. So this is something we can solve for now. We want to find out what x is. We're going to find out what this x is. So we need to get that x by itself. All right. One way we can do this, we take a look. Ooh, sine 35 degrees. That's something we practiced earlier. So on your calculator, hit sine and then 35, and we should get 0.574 equals. On the right-hand side is still x over 9, and we want to get the x by itself. We can get rid of the 9 by multiplying, but what I do to one side, I do to the other. So now 9 times that 0.574 number should come out to x equals 5.166. So we've got an answer for x, and I'm going to box that because that is our final answer, and let's see if it makes sense on the picture. The longest side on the triangle should be the 9, and we've got a side that's about 5.2-ish. So that makes sense. All right, it should be smaller than the hypotenuse. All right, let's try another one. So, for example, we want to go ahead and solve for x. It's another right triangle, because remember trig only works on right triangles. They've got it marked off a 55-degree angle, 7 here, x here, and that's all they give us. So we want to find out what x is. The way to start this, mark off your angle. That is your theta. That symbol's theta. And let's label the sides. 7. Is that the opposite, the adjacent, or the hypotenuse? Let's see where it's located. It's across from the right angle, so that is the hypotenuse. And the x, it's either the opposite or the adjacent. Opposite would be the one down here. This is the side touching it, so this is the adjacent. So again, thinking about to SOHCAHTOA. We've got hypotenuse, h. We've got adjacent a, so h and a are that one in the middle, cosine. So cosine theta equals, and then it goes adjacent over hypotenuse. And let's fill in everything we have. Cosine. Theta is a number this time, 55 degrees, equals. Adjacent is the letter x that we're trying to find. Hypotenuse is 7. And look, we can do that cosine 55 again on the calculator. Cosine 55 gives me a 0.574 equals x over 7. And then a 7 on the bottom, we can get rid of that by multiplying. But what I do to one side, do the other. So in the end, x equals, we should get a number that's smaller than 7, because remember 7's our smallest side. And once we multiply those two numbers together, we get 4.018. Go ahead and box that. And yep, that looks like it makes sense on the picture. All right. So there's going to be one thing different about this next example. So again, it's a right triangle. This corner is marked off as a 65 degrees. This side's x, this side is 5. All right, so mark your focus angle, the 65. We never use the 90, and then this one over here doesn't have any info, so nothing to do here. So 65 is my theta. Let's label the sides. I don't know anything about the hypotenuse. There's nothing over here. Nothing here. But across from the 65 is the 5, so that's called the opposite. So that leaves me with only the adjacent left. So adjacent is x, opposite is 5. So, toa. I've got opposite and I've got adjacent. I've got O and A. That's this one here, tangent. So tangent of theta equals O opposite over A adjacent. And let's fill it in. So tangent of 65 is my angle. Opposite is 5. Adjacent, x. So the reason this is different than the other ones is x is now on the bottom. Usually x was on the top. We still want to solve for x. We still want to get it by itself. But here's going to be a shortcut for you. If x is on the bottom of your fraction, all you got to do is take this piece and the x and flip-flop their places. Okay? It'll make it a lot faster for you. So if I flip-flop them, it says x equals 5 over tangent 65 degrees. Now the x is all by itself, and then everything on the right you can just put into your calculator. And I'm going to do it step by step. So x equals, keep the 5 on top. Let's find out what tangent 65 is. On the calculator, if you put tangent 65 degrees, you get 2.145. And then finally just divide those two numbers, and you get 2.331. Now if they give you units like feet or inches or miles, don't forget to put that. But for right now, there are no units. So that's the answer I got, 2.3-ish, and let's see, does that look like it's good? Yeah, that looks like it's smaller than the 5. It's in the right neighborhood. If you get something outrageous, like 100 or 1,000,000, then something's probably up. Okay? So the thing to remember today, if the x is on the bottom, flip-flop. If x is on the top, just go ahead and solve it out normally. Again, make sure you know how to work your scientific calculator, which everybody should have by now. If not, you've got your phones, or you can go on Desmos or online calculators, but make sure you know how to use them.